Problem 19. How many solutions does the following expression have? So when you're trying to find the solutions to a given trigonometric function such as this one, you typically want to isolate one trigonometric function and derive the solutions from there. So in this case, we have both sine and cosine, and that's typically kind of hard to evaluate. So let's try to isolate one variable and simplify things. In this case, I would choose sine because sine is typically easier to work with. In this case, sine of pi over 2 of cosine x is already in terms of sine, but cosine of pi over 2 times sine of x is not. So is there some way that we can turn it into sine of x? Well, we can, because we know that the cosine of some x will be equal to the sine of pi over 2 plus that x. In this case, x is equal to pi over 2 times sine of x. So if we were to have this understanding, then this would be equal to sine of pi over 2 plus pi over 2 times sine of x. If you were to rewrite it into this expression, then that means the argument on this side must be equal to the argument on this side. So simplifying things, pi over 2 cosine of x must equal pi over 2 plus pi over 2 sine x. Since everything has a pi over 2, then we can divide pi over 2 on both sides to get 1 times cosine of x is 1 plus sine of x. So if we were to have this expression, then we can say that the cosine of x is 1 plus sine of x. So in other words, cosine of x minus 1 must equal to sine of x, right? So with this, we can find some special values of x and the special values of cosine. So if I were to have a table right here, x special values for trigonometric functions will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So since the interval is only within 0 and pi, we only consider this much. Sine of 0 would give 0, cosine of 0 would give 1, sine of pi over 2 would give 1, this would give 0, this would be equal to 0, and this would be equal to negative 1. So from this, we know that it must satisfy, we can say this one, right? It must satisfy this expression. When x is equal to 0, that means cosine is equal to 1. So that means 1 minus 1 must give 0, and a sine of 0 is 0. Sine of 0 is indeed 0. So when x is equal to 0, this will be a valid solution. Let's try pi over 2. When x is equal to pi over 2, the cosine value will be equal to 0. And that means 1 minus 0 must give 1. And what is sine of pi over 2? Sine of pi over 2 indeed gives 1. So therefore, 1 and 1 matches, so x is equal to pi over 2 would be another solution. But what about x is equal to pi? X is equal to pi, well, that means cosine must equal negative 1. So negative 1 minus 1 must give negative 2. And obviously, none of these values are negative 2, so x is equal to pi would not work. And we will be done with answer choice C. But you might be thinking, hey, why did I not try pi over 6 or pi over 3, which are also special values? The reason for this is because there's a square root. Pi over 6 has 1/2 or root 3 over 2. Obviously, root 3 over 2 cannot cancel the square root, so it would never derive a quantity that's either 1 or 0. Therefore, from these three conditions, we derive that the answer choice is C.